Today, we're going to continue looking at graphs of sine and cosine. Recall that we start with some default graphs of sine and cosine, and then we start making adjustments to them using operations of multiplication and addition, either before or after the trig function is applied in the order of operations. The two operations that we focus on are multiplication and addition. Multiplication will produce a stretch, and addition will produce a shift. If we apply the operation before the trig function, that will produce horizontal effects on the graph. So multiplication before will produce a horizontal stretch. Addition before will produce a horizontal shift. If we apply the operation after the trig function, then the effect will be vertical. So multiplication after the trig function will produce a vertical stretch. Addition after the trig function will produce a vertical shift. So multiplication after the trig function will change the amplitude. Addition after the trig function will change the middle. The middle shifts up and down. The amplitude is a stretch of the function. Addition before the trig function will produce a horizontal shift. This will change where the start of the function is, and start has to go in quotes because the graphs go on forever. So I say the start. Multiplication before the trig function will produce a horizontal stretch, so that will alter the period. So there are four things that we want to identify when we're looking at an equation or a graph: the middle, the amplitude, the period, and where we consider the start to be. Right. I'm going to write down, let's write down our graphs, write down our equations of sine and cosine with the letters we were using, A, B, C, and D, and talk about how to read what those numbers tell us. So can't remember if I was using theta or x before. I'm just going to switch to theta. No, can't remember. I'm going to write two, one for sine and one for cosine. And the thing that we want to focus on are these four values: how we change the amplitude, how we change the middle, how we change the start, and how we change the period. I actually like the middle to be listed first. So I gave each of these a name. So I called the amplitude A. And I think I was using D for the middle. The nice thing about the vertical stuff is that it just shows up as is. So the middle is D. If there's a constant term, that's going to be the middle. Then we're going to have plus some amplitude, which was A, times the trig function. So cosine of. So whatever happens in the cosine, multiplication by A happens after the trig function, and then adding D happens after. So these are both going to be vertical changes. The period and the start are both things that happen before the trig function. So there's going to be some coefficient of x that represents a multiplication before, and usually I use b for this. And for the start, I use the letter C. So there's an A, a B, a C, and a D. So the order of operations of things that happen to theta. First, we subtract C. We multiply the result by B. So those operations are before the cosine. Then we find the cosine of the result. Then we take the result and multiply by A. And then finally, we add D. And we can do this for the cosine or the sine. Have D in the middle. Plus some A times the sine of B, which is a multiplication, times theta minus C. Nice, give it a different name. All right. Now, the period as a number does not just show up in the equation. We know that this number B is getting multiplied by theta. That is a multiplication before the trig function. That's a multiplication, B times theta, and it's happening before the trig function. And so this multiplication by B will adjust the period. B says how many times we go around the circle, how much faster we're going around the circle. So what you want to remember is that the period of a sine or a cosine is 2 pi divided by B. Period is the thing that we need for the graph. B is the number that we need for the equation. The relationship is that the period is 2 pi divided by B. We think about the default period being 2 pi. And so if B is equal to 2, then we're going around twice as fast. So the period will be 2 pi divided by 2, or just pi. If B is 0.5, then we're going around the circle half as fast. So the period will be 2 pi divided by 0.5, which is 4 pi. When we talk about the start, we're talking about plus or minus the cosine of 0 and plus or minus the sine of 0. Not theta equals 0, but 0 plugged into cosine or 0 plugged into sine. And we have 4 options. We either have a plus cosine or a minus cosine, a plus sine or a minus sine. So the way I like to think about the start is I like to think that positive cosine starts at the top. Negative cosine starts at the bottom. Positive sine starts at the middle, going up. And negative sine starts at the middle, going down. One of the things that we're going to notice about graphs of sine and cosine is that although we will have the graph of the function, we will just write an equation for the function, because there are an infinite number of descriptions of the function using an equation. At the very least, there are 4 that will happen just in the first cycle: plus or minus cosine, plus or minus sine, depending on whether we think the start is at the top, the bottom, the middle going up, or the middle going down. Remember that when we talk about the start, it's the cosine of 0 and sine of 0. So that's why I write theta minus c, and then so we can identify c as the start. So if c is 30 degrees, then theta is equal to, we have 0 being input into cosine or sine when theta is equal to 30. So we get to 30 minus 30, then we're starting at 30 when it says theta minus 30. Let's write down one with example values for A, B, C, and D. Calculate what we need to calculate, and then draw a picture of what's going on. Any questions before we go on?
What does it mean when B is negative?
If B is negative, then we're going to flip the, multiplying by a negative flips things. So if A is negative, things are getting flipped vertically. If B is negative, things are getting flipped horizontally. So when we list the period, we would want to list the period as being positive, and we wouldn't want to write cosine of, say, -2 theta. We're going to want to adjust that so it's a cosine of a positive. Let's do a few examples, and then we'll see why we don't have to worry about B being negative. Or when B is negative, we can look at that and say, we need to fix that. Let's look at an example. Let's identify the 4 things: the period, the amplitude, the middle, the start, and the period for this function. Let's say y equals -3 plus 5 times the cosine of 2 times theta minus pi over 6. We need to interpret what all these numbers are doing to our base model cosine of theta graph. Look at the order of operations of things that happen to theta. The first thing that happens is we subtract pi over 6. The second thing that happens is we multiply by 2. The third thing that happens is we do the cosine. The fourth thing that happens would be to multiply by 5. And then the last thing that would happen is we subtract 3. So this is the order of operations. This is what happens to the theta. So the minus pi over 6 and the multiplying by 2 are operations that happen before the trig function. So these are horizontal changes. The times 5 and the minus 3, those are going to be vertical changes. The multiplication is going to be some kind of stretch. The addition and subtraction will be some kind of shift. So let's read what the equation is telling us. This -3 says that we should put the middle at -3. So if I draw the middle, that will happen at -3. This +5 is being multiplied by the cosine, so my amplitude is 5. So from the -3, I'm going to go up 5 and down 5. Because that's my amplitude. The amplitude goes from the middle to the top or from the middle to the bottom. So I use the amplitude to determine where the top is and the bottom. Two is the coefficient of theta, and that's going to adjust the period. The period is 2 pi divided by b. So the period is 2 pi divided by 2, or just pi. The pi over 6 is a horizontal shift, so we're going to start at pi over 6. The other thing that we need to notice is that we have a positive cosine. So we'll start at, I spelled 6 wrong. We're going to start at pi over 6, and since it's positive cosine, that's going to be the top. So we're going to start the top at pi over 6. Cosine starts at the top at a quarter period. We're at the middle. I don't know why I put these in between. Another quarter period, we're at the bottom. 3/4 period back to the middle. 1 full period, we're back at the top. So we're back at the top at pi over 6 plus the period. So the top happens at 7 pi over 6. We'll be at the bottom at half of a period. So we take the start pi over 6 and add half of a period. Pi is 1 full period. We'll divide that by 2. So pi over 6 plus pi over 2. Or we can take the average of 7 pi over 6 and pi over 6. 7 pi over 6 plus 1 pi over 6 is 8 pi over 6. So pi over 6 plus pi over 2 will be 4 pi over 3. Just average these two. No, I didn't divide it by 2. I can do fractions, I swear. I forgot to divide it by 2. So we want to know, we know that we are at, I didn't split these up though. So we know we're going to be flat at the top and we'll be flat at the bottom. Now we just need to draw a cosine so that it goes from flat down to the middle, down to the bottom, back up to the middle. And now we figured out we have a period. We'd have to start at pi over 6. One period will end at 7 pi over 6. We calculated we read the middle as being a -3. The amplitude is 5, so -3 plus 5. We can get the top. -3 plus 5 is at +2. And the bottom is at -3 minus 5. So the bottom is at -8. Let's take a look at this equation in Desmos to see how we did finding the points. Oh, of course, I covered up Desmos. Okay, let me hit share screen over to Desmos. Now let's take a look at a basic graph of y equals cosine of x. Y equals cosine of x. Here's where we start at the top, 0, 1, hit the middle at a quarter period, bottom at a half period, middle going up at 3/4 period, and back to the top at 1 full period. One of the things that we did with the cosine to the x is we subtracted pi over 6. So now the top happens at pi over 6. The middle happens at a quarter later. The bottom, the middle, and then the top happens at 13 pi over 6. Oh, because the period is still 2 pi. I forgot it's 2 times pi over 6. Now I've compressed the graph horizontally. So here's my top pi over 6. Here's the next top at 7 pi over 6. Here we are halfway at 2 pi over 3. Oh, I forgot to calculate 5 pi over 12 and 11 pi over 12. But we did a shift from cosine x, where the top was at, I don't know the intersection, where the top was at 1 or at 0, 1, horizontal shift of pi over 6 units to the right, move the top to pi over 6. Then we compressed by multiplying by 2. Then we're going to stretch the graph with multiplying by 5. And then we're going to shift the graph by subtracting 3. So there's our original graph. Our middle is at y equals -3. Our top is at y equals 2. And the bottom is at y equals -8. So what we predicted was the case. We've got a top at pi over 6 and 2. The next top happens at 7 pi over 6 over 2. That's one cycle later. The bottom is at 2 pi over 3 negative 8. And then the two middles are at 5 pi over 12 and 11 pi over 12. And so there's one cycle from the top to the middle going down, to the bottom to the middle going up, back to the top. Any questions? So this is what we want to be able to read. We want to be able to look at an equation where I adjust a middle, an amplitude, a period, and a start. The other part of reading the start is a positive or a negative, cosine or sine. That gives us 4 options. And then we want to be able to calculate, once we have the start down, figure out where the end is, and then figure out where all the points in the middle are. Then compare that to what the graph is telling us. The reason that we don't just appeal to Desmos to figure out these points based on the graph is that part of knowing, becoming proficient in a thing is not just being able to produce the graph. It's important, it's also building experience so that when we look at a graph and look at an equation, we can see if there's something wrong right away. So we can tell that if something has been typed incorrectly, so we could look at this graph and say, no, this is wrong because the period here is much too long. The period here is 4 pi, and the period is supposed to only be pi. So there must be some error in our calculation or in our inputs. Or to know that this should have a middle at -3 and a top at 2. And so if we had an error in the inputs, like, well, no, the bottom shouldn't be -2, the top should be +2. We can see by the function, we can see by what's written here that this graph, if the graph is correct or not. So we're trying to build some kind of intuition about what the graph should look like based on the numbers that we see in the equation. So proficiency is not just about being able to calculate things quickly or to produce a graph quickly. It's about being able to look at some information and know right away there's something wrong. I think I've told you the story of one of the members of my gaming group is an accountant, and he is exceptional at arithmetic. Not because he can calculate things faster than I can, even though he can calculate things faster, way faster than I can, but because he can look at a set of data and identify right away that there's something wrong with the set of data. Something has gone wrong in the calculations because this end result does not match with the data. You know, he'll identify that there's something wrong and he'll be able to find it. He's way better at calculation than I am. I just happen to know more math than he does. That's just the difference. I'll look at a set of data, and I do this all the time. I write down some data and I write down a number wrong or punch it in the calculator wrong. And I just keep on going with the problem. And it doesn't always occur to me right away, something has gone terribly wrong. Because I'm like, oh, that's what the calculator told me. And then I just kind of keep going with the problem. You know what I mean? All right. So your job is to be able to look at an equation and find the 4 things about the graph: middle, amplitude, start, period. Or to look at a graph, identify those 4 things: the middle, the amplitude, the start, and the period, and write down an equation for the graph. Any questions? Comments? All right, so these assignments will show up less as quizzes and they'll show up as discussions. So I'm going to post a discussion which will have a picture of a graph and it'll say write an equation for this graph. You'll have to write type a response before you can read other people's responses. So you're on your own for your first response, but then of course you can just go make an edit to your original response. Any questions? Comments? Any thoughts? All right, that's going to do it for today. I will see you all on Thursday. Everybody have a good couple of days, and thanks for playing.